Hi, this is my Lab 1 presentation. This is Tiffany Costa. I'm a little sick, so don't mind that, please. But there's the introduction, main ideas, our lab, and conclusion. So for our introduction, the purpose of this lab was to graph the projectile motion of an object. In our case, we used an expo marker against predicted data versus our actual data. We put the expo marker up against the table, so it only moved in the x direction, so we only worried about the x direction. We filmed a video of our expo marker moving and then use the tracking app to graph where exactly the position would be with the velocity using the video. And then we also coded a program that would predict where the expo marker would end up in the certain time intervals with its estimated velocity, and then we compared those. The physics ideas in this lab are that projectile motion and kinematics equations can predict how objects move. Obviously ours was only moving the x direction, so we can use these kinematic equations, and we did end up using velocity initial and velocity final just to find the final velocity, and then with that we found the displacement equation. We also use the position update formula, where it's like if there's constant velocity over a certain time interval, we can estimate where the position of the object is going to end up. The predicted result from this lab is a video of our projectile and a graph of the projectile's movement, predicted versus actual, using our code and then using our actual video, which using our program, the tracker program, that we could graph those. Kinematics equations are used to predict the movement of an object based on what forces are acting on the object, and we use these equations in our code to kind of predict where the expo marker would end up. There's our expo marker. Our system was the expo marker moving, and the surroundings were the table and also the classroom, but since it was only in the 2D, our surroundings was the table. According to our tracking information, we altered our code to align with the time intervals that were given in our tracker program video. That was every 0.033 seconds the position would update. So we did that, and so in Excel we put in the positions and the velocities of our tracking software, and then using our code we also copy and pasted that data after the code ran. So this was the code we put in. It's basically a loop that will keep running the position update formula, and will update with the certain positions when we put our time intervals. You can see that my delta t, which is the change in time, is 0.033, which is how big the time step was when we recorded. And then these are the graphs we got, and then it also outputted all of the values for every single time interval. And then our tracker, we put in our video, and then we chose the expo marker as the center. And as you keep graphing it, it graphs here where the X is ending up, and then we don't listen to this, and then here are all the inputs that we got. So, and then when we put in all the data and graph it, we got that there was a slight difference. I mean, they both started from 0, but then from that, the observed did move a lot more than the predicted did. And our conclusion, possible error was human error. We could have pushed it a little too hard, a little differently than how we could predicted it. And the purpose of this was how we can demonstrate the motion of the projectile can be predicted with kinematics equations. There's also air resistance, friction on the table. In an ideal scenario, our expo marker would have never slowed down, as it was projected in the x direction and it did not experience acceleration. One force that always acts on objects is gravity. Since our expo marker was not thrown or affected in the y direction, we neglected gravity because it doesn't work in the x direction. So from this, we can determine that in the x direction we can use these kinematics equations to predict, because even though they were slightly different, our prediction code was very similar to our actual video of us pushing the expo marker. Thank you.